Back. We are now recording. So, quick announcement that I want to make. You know how when you guys join the room and it says you got to wait for somebody to join? The reason, so and then I have to stop what I'm doing and I have to admit everybody. If you will log into Teams, then you can join automatically and I don't have to let you in. And so I would just encourage you guys to just log in using your UVU ID, and then I don't have to let you in. So just wanted to make that quick announcement. All right, so today we're going to be doing the ellipses. So I wanted to show you a quick, why is it not here? Little animation, kind of like we did yesterday for the parabola. Oh, I have a different one for the ellipse. Here we go. And so, share my screen before I do this so I don't miss any animation. Okay, so here we go, making of an ellipse. Unable to open, why? Well, that's the pits. Okay, you're driving me a little crazy here. Copy. If I can do it myself. No, it didn't work. Well, we might dispense with this if it won't work. Oh, that's the pits. Guess I should have mentioned that or checked that sooner, but I thought those would work. Dang it. Oh, this might be it. Okay, here we go. This is, I'll have to get used to this one. It's my new thing. How to create an ellipse. Okay, so if you took a nail, so these two green dots here represent a nail. And then if you took a string and you took a pencil, you can draw an ellipse by just using the string to draw your ellipse, okay? So the idea is think of these as two nails and a string, and then you just draw your ellipse that way, okay? Now the other, so those two nails right here, these are called your foci or focus. So you've got two focuses, two foci essentially. There's also an ellipse. I'm going to keep that there. We've also got an ellipse called the whispering gallery. Hopefully I can find that here. But the idea here is, I don't see the GIF, but the idea here is if you stand on one focus and you whisper, the sound waves bounce off the top of the ellipse, and then a person standing on the other focus can hear you. And so they call these a whispering gallery because you can whisper from one side of the room, and the person, if you're on one focus, the person's on the other focus, you can hear it. It's a perfect. They call it a whispering gallery. So that is another benefit or whatever you want to call of the ellipse. So anyway,
amphitheaters and coliseums.
Is that why amphitheaters what?
Is that why amphitheaters and coliseums are that shape?
Well, I don't know that they do that on purpose for that, but like I know the Salt Lake Tabernacle, they built that. I think a bridge builder was the one who designed it because he wanted to make it very large, and that was the best way to make a large building, was to make it an ellipse, because you know, they didn't have steel back in 18 or 9. Yeah, they did that in the 1800s. And so they used a bridge builder. Basically, they took a boat up and made it upside down, and that became the roof of the tabernacle. So, all right. So let's talk a little bit about the ellipse here, and the so here's some of your properties of your ellipse. And so basically, now they've got in here the equation. Well, here's how I'm going to do it. So if I have x squared, I should have underlined this, x squared over a squared. Oh, I forgot to stop underlining. A squared plus y squared over b squared, the entire thing equals 1. Okay. Now, they make a big deal about the a's and the b's, but here's what I'm going to say. The bigger number, when we're talking about a and b is the major axis. Smaller number, when we're talking about a and b, is the minor axis. Now, they've got it written out twice in the book, but I think this is an easier way to remember. I don't care where your A and B is. I just want the bigger number to be your major axis. The smaller number is your minor axis, okay?
Could you type in a bigger font?
Now, cut off what I just wrote. Okay?
Okay.
Is that better?
Yeah.
All right, are you on your phone or something?
No, it's just I couldn't tell between like an A and a B because it was just really small. So I don't know.
Oh,
It was small for me too, so this helps.
okay. So, your focus, and so here's the other thing that I'm going to do that's a little bit different than the book. Your focus is at either C0, maybe I should put plus or minus. I'm going to do that. Plus or minus C0, or 0 plus or minus C. And it depends. Focus is on your major axis. Okay. So whichever your major axis is in the x direction or the y direction, that's how it's going to be. Okay. And to find C, C squared equals A squared. Here, C squared equals A squared. I'm going to change this. It's the big number squared minus the small number squared. And then you don't have to worry about, is A in the first spot, is A in the second spot. I know they make a big deal about that in the book, but I'm just going to say, just use the big numbers and the small numbers. That's the easiest way to figure that out. So the easiest way to graph one of these, let's just do a quick graph here. So if I have x squared plus y squared equals 1. Then I'm going to underline these. So they look like a fraction. And then I'm going to have x squared over 9 plus y squared over 4 equals 1. Okay? And if I say I want you to find the foci, the vertices, and the graph. Okay? Now the easiest way to do this is okay, so I've got my graph here. I'm going to try to add some tick marks here. 1, 2, 3, 1. God, these are huge tick marks. I'm sorry. 2, 3, 1, 2, 3. I wish I had some graph. I'm going to have to find some graph paper and maybe this will be easier. Okay, so the idea here is, as we look at this, what is your A and your B? A equals, B equals.
A is 9 and B is 4.
So A squared is 9, so therefore A is 3. Does that make
Okay.
sense? And B squared is 4, so B is 2. Okay? And so now, in this case, my A is my bigger axis. So A is going to be, this is going to be my major axis. My major axis is on the X variable here, okay? So the idea here is I'm going to go out to, I'm going to go out 3 and 3. I'm going to go up 2 and 2, okay? Now, so my vertices, and I think the book only lists the major axes. I would prefer that when you're doing this on your test that you list all 4. So I've got, so your vertices are going to be plus or minus 3, 0, and in the vertical direction 0 plus or minus 2. Okay, so I've tried to mark those on there. Then, of course, the easiest thing to do is at this point I can draw my ellipse. That actually looks pretty kind of circular there. Okay, so I've sketched the graph. I've got my vertices. Now I need to find my foci. So in this case, c squared equals the big number squared minus the small number squared. So in this case, c squared equals 9 minus 4. So c squared equals 5. So c equals the square root of 5. Okay. Now, if I'm to draw my foci on the graph, we know that 2 squared is 4 and 3 squared is 9, so it's in between 2 and 3. And so if I were to draw these, it's always on the major axis. So I'm just going to put in a little circle there, a little circle there to represent my foci. And that will be pretty good. Okay, does that make sense?
Yep.
Okay. All right, so the length of your major axis, if it got 3 here and 3 here, your length of your major axis is 6. If this is 2 and 2, your length of your major axis is 4. So let's do another one, and this time I'm going to pick on somebody to help me. Okay, go ahead.
So the foci goes only on the big, uh,
The
big
major
number,
axis.
the
Yeah,
major
the
axis.
big number.
Okay.
Yeah. Yeah, so
Okay.
you're, in this case, your x direction is your major axis, your y direction is your minor axis.
Okay. All right. Thanks.
No problem. All right, so now let's do another one. This time I'll have you guys do it. X squared y squared equals 1. I'm going to underline these so that it looks like a fraction. And then on the bottom, I'm going to have a 9 and a 16. And so let's go ahead and we'll do this one. So I saw Camilla. Are you here, Camilla, still?
Yeah.
Can you help me do this one?
Yeah. So A would be 3.
Okay, A is 3.
And B is 4. So B would be the big number this time.
3, B equals 4. Okay.
And so you would do the 3 and 3 on the y-axis, so 3 and -3, and then 4 and -4 on the x-axis, or is it opposite?
No, you said it right. So we're going to go up and down. How many?
3.
No, we're going to go up and down 4.
Oh, 4. Okay.
So we'll go up and down 4. And we'll go left and right 3. 1, 2, 3. I need to find out how to get some good graph paper on this. I'll see if I can do that next time because we're going to be doing a lot of graphing and I don't want to do this every time. Okay. And so then we can draw our ellipse here. My ellipse actually looks better than I thought it would. Okay. So in this case, how would you find your foci?
So the foci would be c squared equals 4 squared minus 3 squared, so 16 minus 9.
16
which is
minus 9.
7.
So your foci, so C
Square
in this case, equals the square root of 7, right?
Yep.
Okay. So the square root of 7 is in between 3 and 4, basically. So about 3.5. We'll just call it 3.5. So if I were to draw these on my thing, about 3.5, and it's going to be here. So it's going to be about right there and about right here. And so those coordinates would be what? How would you write that as coordinates for your foci?
Are you saying it's 3.5? Is that what you just said?
Go ahead and leave it as the square root of 7, but yeah, about 3.5.
Okay, so it would be 0 square root of 7, or plus or minus square root of 7, I guess.
0 plus or minus the square root of 7. Perfect. Okay. And so obviously when you're writing that on paper, you can do the real square root sign, but yeah, that's perfect. Okay. All right. So now I want to do 2 more things. Let's talk a little bit about eccentricity. Now, I will say this. What if a squared equals b squared? What would your ellipse look like? And I'll throw that for anybody. Does
Wouldn't
anybody
that
know what it
just
would look like?
be like a circle?
That's exactly right. It would be a circle. Okay. So if a squared equals b squared, you've just simply got a circle. Okay. So the idea here, eccentricity, tells you how oblong it is. Okay. And so so eccentricity E is always going to be, put a 3 there, E is always going to be between 0 and 1. Oops, 0 less than E less than 1. That's what I meant to do, okay? And so your eccentricity is basically the formula E equals C divided by A, okay? So what we could do is, if we go back to the previous problem that we just did, we could figure out the eccentricity, which would simply be the square root of 7 divided by A, and A, well, A meaning the big number. And so in this case, I'm going to put it by 4. In fact, maybe I will change my formula. Instead of saying A, I'm going to change the formula. The book has A, but I'm going to say it's whatever the big number is. Big number. Okay. So this one's eccentric in the y direction. This one's eccentric in the x direction. And so it's going to be C divided by whichever is the big number. Does that make sense?
Mm-hmm.
So in this case, your eccentricity would equal the square root of 5 divided by 3. Okay. All right. Now, the last thing I want to do is find the equation of an ellipse with a foci at 0, comma, plus or minus 8, and eccentricity equal to 4 over 5. Okay. So here I'm going to pick a different color for this one. I'm also going to erase part of this so I can put it over here. Okay. Now, as we do this one, okay, I'm going to, okay, so your foci are 0 plus or minus 8. So your major axis, maybe I'll just add this here really quickly. So your major is going to be the y-axis, basically, right? Major equals the y-axis. Does everybody see why?
Major.
Because the foci are at 0 plus or minus 8. Your foci are always on your major axis, and so in this case, I'm not going to draw my tick marks, but that's going to be 8 up, and this is going to be 8 down. And that's my foci, right? That's
Yep.
not my vertex, okay? So that is at 8. So my vertex is going to be higher than that. So in this case, we know right off the bat that C equals 8. Okay. Now your eccentricity is going to be C. Eccentricity is going to be C, which in this case is 8, divided by your big number, which has got to be obviously more than 8. So we know that that's the major axis. Okay. So one way we could do this is we could do some fractions. So if I know that my eccentricity is 4/5, we can make that as similar fractions as 8 over what would be the denominator to make that a similar fraction. It would be 10, right?
10.
Yeah. Okay. So in this case, we know that my big number is going to be 10. And so if I put up here, this is 10. Okay, so we know that, okay, so when I'm making my equation here, I'm going to have x squared over something plus y squared over something equals 1. So I'm going to underline this. Okay, and I'm going to underline this. Now, we know in this case that 10 is going to be right here because my y is going to be my major axis. Okay, so now all we need to do is we need to figure out what this is. Okay, so if we know that my
Would that be
number,
just 10 or 10 squared?
that's a good question. So remember, when my eccentricity, it's just c over the big number, and so when we're doing this, oh, you're asking about this number here? Yeah,
Yeah.
actually, it should be 10 squared. So that you're right. That should be 100. Thank you. Okay. So we know that c squared equals the big number squared minus the small number squared. Okay. So in this case, we know that c is really 8. So that's going to be 64 equals 100 minus small number squared, which is going to be small squared. Okay. So then I can subtract, and I'm going to get negative 36 equals the negative, equals the negative small number squared. So in this case, and that's really all you need. I'll multiply those by -1 to get rid of the small number. And so in that case, this value here is 36. 36, what's wrong with my other thing? Okay. And so really what this is telling me, if I were to finish drawing this, okay, this is going to be -6, -6, and +6. Okay. And so then I can finish this out. And now my ellipse looks like, oh, I didn't draw it down here, but it's just a little bit lower there. And there you have it. So I was able to not only find the equation, which is this equation right here, but I was able to draw it as well. I should use my ellipse tool. Probably, yeah. In fact, here, we're going to try this again. I don't know why I wasn't thinking of that sooner. That's a much better looking ellipse. That's what I should have done in the first place. What was I thinking drawing that with a pencil? All right, so except for actually, I need to stretch this out because that should be up to there. Actually, this one should be lower too. That should be down to there, okay? So those should be ±10, ±6, okay? All right, so there you have it. That is section 7.2. And I will fix your quiz grade, so sorry about that. Any last questions before I let you go?
Nope.
Do you guys want this? Want me to post this up there as notes?
Yep, I do.
Okay. Will do then. Okay.
Thank you.
You're welcome. See you all tomorrow, and hopefully the quiz will be better than today.
Yeah.
Thank you.
Welcome. We'll see you.
Bye.
Bye.